Hi again. In this last module on anaerobic digestion, we'll talk about using the products of AD, the gas and the digestate. I will try to explain what needs to be considered so that a biogas facility can be sustained and maintained. Before we do this, however, let me quickly sum up what we have heard about AD until now. So, we have looked at some issues of the substrate chain. We have talked about particle size. We had talked about volatile solids of different waste materials. I also described the biochemical process stages and the main parameters, which are contained in here, and some typical digester technologies. So what now is left to do is to cover the product chain, the gas and the digestate. We will also discuss the issues around sustaining the whole system and answering the question, when can anaerobic digestion be an appropriate treatment option for waste management, and when not? So, now with an appropriate digester and good operating conditions, the reactor will produce biogas. This biogas is saturated with water vapor. And in the first instance, the water vapor moving through the pipes will condensate and moisture will collect as water in the pipes. We will need to remove this moisture. We call this dewatering. We can remove the water at the lowest point in the pipes. If this water is not removed, it can block the pipes, hindering flow of gas. That is why you will need to install a water trap at the lowest point in the gas lines. There are different types of water traps you can install. Here are two examples, an automatic one and a manual one. Both have T-joints at the lowest point in the gas pipes and a water storage unit below the T-joint, where the condensate can flow into. The automatic trap empties itself when full by using a U-bend overflow, whereas the manual water trap is emptied by opening a valve. The biogas produced in the reactor will vary during the day according to feeding patterns and also ambient temperature changes. Biogas production also continues during nighttime, when less gas is used, and therefore there are periods when the gas has to be stored. This can either be in the digester itself, as in the top part of the fixed dome digesters, as we had seen before, or in bags or balloons, like in this unit in Indonesia. Gas can also be stored with medium or high pressure in gas tanks. This can be done with compressors, but of course, this requires energy. The Indian Institute of Technology in Delhi is engaged in research on bottling of biogas for use as fuel in three-wheeled vehicles. They combine conditioning and cleaning of biogas and compression. In an uncompressed form, the energy content of 1 cubic meter of biogas corresponds to around a half a liter of diesel. As a rough rule of thumb, about 10 kilograms of biowaste are needed to produce this 1 cubic meter of biogas. For all use in machines, engines, or generators, biogas needs to be conditioned. We could also call this cleaned. The goal is to remove water vapor, which we've already talked about, but more importantly also hydrogen sulfide, which is very corrosive, and CO2, which has no energy value. Removing hydrogen sulfide is what we call desulfurization. We can do this with ferrous oxide, which then transform the hydrogen sulfide into iron sulfide. We can also do this with water scrubbers, which at the same time also can remove CO2. If we think about biogas application and appliances, actually the most simple way is to use the biogas close to the anaerobic digestion facility for direct combustion. For this purpose, conditioning of biogas is not necessary. A household cooking stove only needs 200 to around 450 liters per hour. Frequently, when no direct use of gas is obvious, methane is fed into gas generators to produce electricity. However, with the conversion losses, we can only retain about 30% of the energy as electricity. The remaining is lost as heat. Besides the gas, another product from anaerobic digestion is the digestate. In wet digestion systems, this is a nutritious slurry with nitrogen, phosphorus, potassium, as well as trace elements. 50% of this nitrogen is available as ammonium nitrogen that can be directly assimilated by plants. So all in all, it's a good fertilizer that can be used in agriculture. But remember, if it's in the mesophilic range, we're not having high temperatures, so if we have pathogenic substances, these are not hygienized. If it is not possible to use this digestate in agriculture, then the digestate has to be treated before disposal, as it still has a high organic load and based on regulations would not be allowed for discharge into surface waters. Remember, no system works without maintenance and care. What does that mean for a biogas system? We need to regularly check for leaks. We can do this with a pressure test, looking if the gas pipes are okay. We also need to check and unblock pipes if required. We don't need to forget to empty water traps, and we need to regularly observe the slurry level in the outlet chamber. It gives us a lot of information on the processes. Remember to not overload the digester, otherwise we will have acidification. And now and then we need to desludge the digester. Typically recommended is every 5 to 10 years, and this will be mostly sand and grit which accumulates at the bottom of the digester. So now we've heard a lot about anaerobic digestion as an option for waste management. But when should we actually choose this option? Well, one aspect is that we need access to a well-sorted organic waste source. What we also need to think about is that we need local skills and experience in construction and operation. Then, need and demand for gas is a requirement. Or we need to have a small power grid which we can feed into. We also need a competitive chance to compete with other energy sources. And this is an economic issue. Finally, we need an institutional environment allowing feed-in into the grid, especially if we're converting gas to electricity. And ideally, we need a demand for the digestate for reuse in agriculture. So let me summarize what we covered in this module. We looked at biogas dewatering and conditioning. We looked at biogas storage options. We looked at gas use and energy content. We discussed what issues are necessary to maintain the system. And finally, we also looked at criteria favoring the choice of using anaerobic digestion for organic solid waste treatment. Thanks for listening.